exercise like we're trying to do today is to try to keep an eye on the bigger picture of the structure around you. We're sitting, we're not at the base of the Snapper Point Formation, but we're pretty close. So these are the Snapper Point Formation rocks. And if you look around you, which way do you think they're dipping? And at what sort of angle? I'll give you some, I'll give a bit more of a hint. The Snapper Point Formation rocks are sandier than the Pebbly Beach Formation rocks underneath, and they tend to not erode as easily. When you're doing a stratigraphic column today, you'll be doing, it's a bit like a horizontal bar chart in terms of the grain size. And why it's drawn like that is because the coarser grained rocks tend to be more resistant to weathering and erosion, and so they tend to form things like overhang. Look back this way to the next little headland that's jutting out, which we're going to be going around. You can see some big sandy units at the top that are jutting out further than the greyer, muddy looking rocks underneath. Okay, so that's why you draw the strat column, the stratigraphic log the way you do, but it also gives us a bit of a marker horizon. So basically the bottom of that overhang, you can see two thick sandy units at the top of that cliff section over there. There's an overhang, so it cuts underneath the softer rocks. That's the boundary between the Snapper Point and the Pebbly Beach Formation. And it's probably a few metres beneath our feet here, and yet there, it's a substantial way up the cliff. So the rocks are dipping this way. Okay, so when we're going to do an exercise just up the end of the platform up here, and then we're going to backtrack along the track because we don't want to go down over the cliff. Just keep an eye on it. When you're doing this exercise, you just need to keep that eye on the bigger picture of what the rocks are doing around you at greater distance, so you know where you're heading stratigraphically, which way the rocks are dipping, and at what sort of angle. If you look at the map that you have, you see they've got different strike symbols that show around about 3 to 5 degrees. Okay, so it's not much, but it's good that it's there, because if they were horizontal, you'd be wandering around the platform looking at the same rocks all day. Okay, or similar rocks. Let's head up.
A couple of things to mention, I guess. You'll see pretty soon that this is a marine unit because it's got marine shells in it here, and that's what you're going to look at. But these things then are going to be marine bed forms because they're in the same unit as the shells. When you look at them, you can see that they're quite coarse grained. Okay, so some of them are actual pebble sizes. You can see that kind of size is in them. To do that, you need a pretty strong current to do it, to move it backwards and forwards. The distance between them, the wavelength, gives you an indication of what the oscillation movement of the waves were. So if you're on a typical continental shelf environment, like this one out here, waves are usually 50 to 100 metres or so apart. So that means up there, not quite as high as where that pelican is, but up there was where the sea surface was when this was actually being generated. And up there, the waves were passing by, say 50 metres or so between the crests of the waves. And they have little oscillation movements backwards and forwards, so that by the time it got down here, what was 50 metres up there is now 1.5 metres down here. And at some point it'll reach a thing called wave base, if you like, where the size of those things will go down to 0 and there won't be any wave motion underneath. And so from this you can get an idea of the fact that there were pretty strong waves, and also that you're in reasonably deep water, okay, tens of metres of water at least, so that those 50-metre wavelength waves got down to 1.5 metres when they got down to the seabed down here. So these are the kind of facts that we'll use during the day to make an idea of what the paleo environment is.
There you go, you learn something every day. And the other thing is it gives you a maximum depth. That's the maximum 4 metres.
Oh yeah, no more than that.
Yeah, so it's deep, but it's not any deep. It's less than 100 metres. Okay.
It's a half the wavelength of the original waves, in fact. So if the The original waves are 50. The base that they can affect is about 25. So if they're 100 metres, about 50. And the big waves, you know, that you get in hurricanes and big storms, they might be 200 metre between the crests. That means that the deepest they can influence is about 100 metres, which is more or less the edge of the continental shelf.